Hi everyone, it's Miss Costa here, and in this video I'm going to be taking you through the Pearson Edexcel GCSE higher paper for November 2021. So obviously if you're doing the Edexcel exam board, this is great for going through past papers, but it's applicable for any exam board because maths is maths and the questions might be a little bit different, but it's still going to be super helpful. Okay, so to start off with, we've got multiplying decimals without a calculator. Now, when I'm multiplying decimals, what I can do is turn them into whole numbers, which are much easier to multiply, and then do the inverse. So let's see, what would I need to do to turn 3.67 into an integer, a non-decimal number? If I multiplied it by 100, that would give me 367. And what would I do to 4.2 to turn it into an integer? I'd multiply it by 10. So if I did 367 multiplied by 42, that's a lot easier to do. Now in total, I've multiplied one part by 100 and another by 10. So in total, I have multiplied it by 1,000. So that's going to be important for when we get our answer. Now you can multiply whatever way you like. I really like the lattice method because it's just fun. So you choose whichever way you want, but I'm going to do this way. So I draw out my little square grid, I divide everything into two using a diagonal, and then I just multiply the single number. So 7 times 4 is 28, 7 times 2 is 14, 6 times 4 is 24, 6 times 2 is 12, 3 times 4 is 12, and 3 times 2 is 6. Now, when we're using the lattice method, all we do is we add up going along the diagonal. So in the first one, I've got 4. In the second one, 8 plus 2 is 10 plus 1 is 11. In the third one, 6 plus 4 is 10, 11, 12, 13, 14. So you add the little remainder as well. 2 plus 2 is 4 plus 1 is 5. And we've got 1 left over. So 367 times by 42 is 15,414. But that's not the calculation I was asked about. I was asked for 3.67. So what did I do to turn my decimals into a whole number? I multiplied by 1,000. So to get it back, I would have to divide by 1,000. Now, the little trick that you can use is when you're multiplying decimals, you can just say, okay, there's 1, 2, 3 digits after the decimal point in my calculation. Therefore, there must be 1, 2, 3 digits after the decimal point for my answer. So 3.67 times by 4.2 would be 15.414. So either you could have divided by 1,000 or you can use the little numbers after the decimal point trick. So that's for multiplying decimals. Now, the next question is dividing decimals, and this is a little bit trickier. So let's just have a think about what happens in general. So let's say I had 60 divided by 20. What's the answer? 3. 3 lots of 20 fit into 60. If I divided both parts of that calculation by 10, I've got 6 divided by 2. The answer is also 3. If I had, let's say, 600 divided by 200, the answer is always 3. So with dividing decimals, as long as you keep each part of the calculation, you multiply it by the same power of 10, your answer will be the same. And that we can look at that using fractions as well. So if you had 600 divided by 200, the answer would be 3. You'd cancel out the divide by 10, and that would give you is equivalent to 60 over 20 or 6 over 2. So whichever method works better for you, but just know that when you're dividing decimals, as long as you've multiplied each part of the calculation by the same power of 10, your answer will be the same. So when I'm dividing, what I generally want to do is have the number that is being divided by, so 59.84 is being divided by 1.6. I want to turn that into an integer to make life easier for myself. So I need to turn that into 16. So I need to multiply both parts of the equation by 10. So that would now become 598.4 divided by 16. Now it doesn't matter that the first part of the division isn't an integer because we can divide into a decimal. So you choose whichever way is best for you. I'm going to do the bus stop method. So 598.4 divided by 16. Now what would be really beneficial, because it is a double digit number, is if you just wrote out this 16 times tables for yourself. This is a non-calculator paper, so it is a little bit of a longer method. So we've got 16, 32 plus 16, 48. Now a little trick if you're not really good at adding numbers consecutively. So multiplying by 2 timed up by 2 again, that would be the fourth one. So you've got 16, 32, 48, 64, add 16 again, that would be 80, add 16 again, so 96. Again, you could have used the trick, so multiply it by 2, because the third multiple and the sixth multiple, so 96, add on 6, my brain's a bit fried at the moment, 102, 112, add 16, 128, and so forth. Okay, let's do a few more. 144, 160. Okay, so now how many 16s fit into 5? I've got none, so we carry the 5. So let's use a different colour. So how many 16s into 59? Well, 1, 2, oh, I didn't change a different colour. 1, 2, 3. So put 3, and from 48 to 59, that's a remainder of 11. How many 16s go into 118? So 1, 2, 3, 4, 5, 6, 7. 7, remainder 6. Okay, and then how many 16s fit into 64? 4. So your answer would be 37.4. Okay, so here I've got Venn diagram, and all I need to do is fill in the information I've been given. Now this little sign here, the little like slanted E, that means the universal set. So it means everything inside of the Venn diagram. Okay, so inside the diagram, you need to have all of the even numbers that are less than 19. So let's just write them out. Now 0 is sort of a contention. You can include it, you don't have to, you won't get penalised if you didn't include it. But so 0, 2, 4, 6, 8, 10, 12, 14, 16, 18 are the numbers that need to be included in this Venn diagram inside the rectangle. Okay, now inside of A, there's 6, 12 and 18, and inside of B, there's 2, 6, 14 and 18. So in the intersection, in this little part here, this is where the numbers that A and B have in common would go. So we've got 6 that is in common to both. So I put it in the middle, in the intersection. And I also have 18, which is common to both. Okay, now what else is left? Well, I've got 12 left over for A and 14 left over, and that would go in B. So let's cross out what I've used so far. I've used 6, 12, 14 and 18. And then I've got all of these numbers left over that also need to go in the Venn diagram. So I just put them on the outside. If they don't fit in either of the circles, they go on the outside. They're still part of the universal set, just not inside A or B. So 0, again, it's up to you whether you put that in or not. I'll just leave it out for now. So you've got 2, 4, 6, 8, 10 and 16 that goes on the outside. Oh, sorry. 2 does not go on the outside because I didn't see that it actually goes in B. So 2 goes in B. I just didn't see that. And that's how you fill that Venn diagram out. Next, we've got subtracting a mixed number. So the first thing we want to do when we're subtracting mixed numbers is turn it into an improper fraction. So 4 1/5. What do I do? Well, I would multiply 4 by 5, which is 20, add the 1, so that would be 21 over 5. 2 2/3, I'd multiply the 2 by 3, which is 6, add the 2, which is 8, so that would give me 8/3. So now you've got 2 improper fractions, and the reason we turn them into improper fractions is so that we can then turn them into fractions with the same denominator, because in order to add or subtract fractions, they need to have the same denominator. So to find the same denominator, I'm going to work out the lowest common multiple. So the lowest number that 5 and 3 multiply into, which would be 15. So I think to myself, what did I multiply 5 by to get to 15? I multiplied it by 3. So the whole fraction must be multiplied by 3 as well. So 21 times 3 is 63. And then what did I do to this side? I multiplied 3 by 5 to get to 15. So I need to multiply 8 by 5 to get to 15, which is 40. Okay, you're multiplying each part of the fraction so that it stays the same number. Like for instance, if you had 2 quarters and you multiplied it by 10, that would be 20 over 40, which is the same thing. You need to keep the fraction the same. So now you've got 63 over 15 take away 40 over 15. And the reason we have fractions almost adding or subtracting when they have the same denominators, because when they have the same denominator, you just subtract the numerators. So 63 take away 40 is 23. You'd be left with 23 over 15. Now it does say give your answer as a mixed number. So we have to think to ourselves, how many times does 15 fit into 23? Once. What's the remainder? So from 15 to 23, you've got 5 plus 3, which is 8. So 1 and 8 over 15. And that's how you do that one. So next we've got a percentage of an amount with a little bit of problem solving. Again, this is non-calculator. So I'm going to use the build-up method. So we're told that at the end of 2017, the value of Tamara's house was 220,000 and Raheem's was 160,000. And that at the end of 2019, Tamara's had decreased. So decreased means go down in value. And the value of Raheem's house had increased, and increased means go up in value. So we need to figure out whose house had the greater value. So we've got Tamara's house, which was 220,000, and we want to work out 20%. So the easiest thing to do for non-calculator papers is start by working out 10%. To work out 10%, little trick, you just divide by 10. So 10% of 220,000 would be 22,000. And to work out 20%, that's double 10%, so we just double it. So Tamara's house had decreased by £44,000. So I'm just going to do that little calculation in a bit. First, let's work out Raheem's. So Raheem's house had increased by 30%, but at least to begin with, let's still start with 10%. So 10% of 160,000 would be £16,000. And what I want to do to turn it into 30%, which is 3 lots of 10%, I'd multiply that by 3. So 16 times 3 is 16, 32, 48. So you would get 48,000. Now remember, Raheem's has gone up in value and Tamara's has gone down in value. So if it's gone up in value, I will add it onto my original amount, and down in value, I'd subtract it. So for Tamara, let's just do that quick calculation. We've got 220,000, take 44,000. So that would give me 0, 0, 0, 0, take 4. I can't do, so I borrow. So 10 take 4 is 6. 1 take 4 I can't do once again, so I borrow. 11 take 4 is 7. And then you've just got 1. So Tamara's house by the end of 2019 would be worth £176,000. And Raheem's would be £160,000. And remember, it's increasing value, so I'm going to add it on. 168 plus 48,000. So that'll be 0, 0, 0, 8. 6 plus 4 is 10. 1 plus 1 is 2. So Raheem's house is £208,000. So at the end of the 2019, you would say Raheem's house has a greater value because it's 208,000, whereas Tamara's is 176,000. Okay, now we've got ratio, and this is where it's really, really beneficial to actually just draw out the question just to visualize what's going on. So we've got Rosie, Matilda, and Ibrahim, and they are collecting stickers. Okay, so the number of stickers Rosie has to the number of stickers Matilda to the number of Ibrahim is 4 to 7 to 15. So I'm just going to draw those out in parts. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's just to visualize what's actually going on. So we are told that Ibrahim has 24 more stickers than Rosie. Oh, than Matilda, sorry. So Matilda has 7 parts and Ibrahim has 15 parts. So Ibrahim has if we cancel out what Matilda already has, so she has 7, so 1, 2, 3, 4, 5, 6, 7 is the same as what Matilda has. So Ibrahim has all of this extra. So in total, Ibrahim has 8 extra parts, okay? And we know that 8 parts are equivalent to 24 stickers, okay? So these 8 extra parts, 1, 2, 3, 4, 5, 6, 7, 8, are equivalent to 24 stickers. So what we can do is divide the amount by how many parts there are. 24 divided by 8 is 3. So we know that each little part is worth 3 stickers, and that applies for Ibrahim, Matilda, Rosie. When we're working in parts, if we can figure out what one part is, that's applicable to everyone. So if we know that each little part is worth 3, how could we figure out what Ibrahim's is? We would just do 3 times by 15, which is what how many parts he has. So that would be 45. And how about Rosie? Rosie has 4 parts, so we would do 3 times 4, which is 12. So Ibrahim has 45, Rosie has 12, and we want to know how many more stickers Ibrahim has. So we would just do 45, take 12, which is 33. And that's it. So Ibrahim has 33 more stickers. Next question, we've got the volume of a prism, and it's in a little bit of a problem solving kind of question. So how do we work out the volume of any prism? And this is regardless of what shape it is. If it's a prism, it means it has a regular cross section, which means if you sliced it at any point, like if it was a cake in this shape and you sliced it at any point, given that you're slicing it vertically, then each little slice would be identical because the shape is constant. There's a constant cross section. So to work out the volume of any prism, you'd do the area of the cross section, and cross section is just the flat bit at the front, the bit that is the same all the way through. So area of the cross section times by the length. Okay, so in this case, we need to do the area of the cross section times by the length to get to the volume. Now let's look at the question. So the cross section of the prism is a right angle triangle. The base of the triangle is length 5. Prism has length 25, and we know the total volume. So we're going to be working backwards with this. So it helps to actually write out what we know. Now, hopefully we know that the area of a triangle is base times height divided by 2. Okay, so the area of the cross section would be base times height divided by 2. In this case, I know the base, which is 5. I don't know the height, so I can just say h, because if you don't know a value, you're going to use algebra. So 5 times h divided by 2 gives me the volume, which they've told me is 750. Oh, missed that one part. So the cross section is base times height divided by 2. Then to find the volume, we multiply it by the length, and that gives you the volume. So 5 times h divided by 2 times by 25 is 750. I can simplify this because it's always good to just simplify when you're working with algebra. So 5h over 2 times by 25 equals 750. Now what I want to do once I've set up this equation is just solve it. To solve any equation, we just divide or multiply or do the inverse operation from one side to get from one side to the other. So in this case, we have got 5h divided by 2 is being multiplied by 25. So we will divide both sides by 25. Now, obviously it's a non-calculator paper, so you know 25, 50, 75. You know 25 goes into 75 3 times. 750 is 10 times that. So 3 times 10 is 30. So you'd have 5h over 2 is 30. 750 divided by 25. You could have also done the bus stop method if you want. Now what would you do? 5h is being divided by 2, so we multiply both sides by 2 to get rid of that divisor. So we're left with 5h is 60. And then 5h, what does 5h mean? Well, originally we know that it just means multiplied 5 times by h. So what do? We'd divide both sides by 5. So h would be 12. So the height of the prism would be 12. So this is a little bit trickier because it's not just area. It's kind of assuming that you know how to substitute into the equation. But if you're confident with knowing how to work out the volume, hopefully this shouldn't be too hard. Okay, another forming and solving equations. They get fun, trust me. So we've got a cube and a sphere. They've given us the volume of a sphere. The surface area of the sphere. And we are told that the surface areas of both shapes are equal. So when we're told something is equal, we know we can set up an equation where one part equals the other and then solve it. So what is important about a cube? Well, a cube, each of the little faces are equal. Okay, so 1, 2, 3, 4, 5, 6. So every cube has 6 faces, front, back, top, down, and then side and side. Now we know that the length of one of the faces is x. Because it's a cube, that means it's a 3-dimensional square, which means each side is equal. So we know the other side, the height here, would be x as well. So therefore, what would the area be of one face? The area of one face would be x squared. And how many faces do you have on a cube? You have 6. So 6 lots of x squared would be 6x squared. Okay, so that is the surface area of your cube. Now we're told the surface area of a sphere, they've given you the formula, is 4 pi r squared. So we'd say 4 times pi times by radius squared. They've given us the radius here. Remember, radius from the center of the circle to the outside. So 3, I can write 3 squared, or I could write 9, depending on how you work and how quickly you simplify. So let's just simplify that a bit. So that would be 6x squared is 4 times pi times 9, and 4 times 9 is 36. So let's simplify that again. 6x squared would be 36 pi. Now, okay, so this is where quite a lot of people get a bit sort of stuck. When you've got to show that question, literally just work out what you would do. And by showing you're working out, you are going to show that. So sometimes people start with the end in mind and they get freaked out because they see what does this k mean? K is just the number that you're going to find out naturally. So just go with your working out, ignore that bit till the end and then see if it matches up. So we've got 6x squared is 36 pi. We're solving this equation, so we're going to try and, we're trying to get x on its own. So we divide both sides by 6. So we're left with x squared is 6 pi. And then we do the inverse of a squared. So x is being squared. The inverse of that is the square root. So x would be the square root of 6 pi. Whatever you do to one side, you have to do to the whole of the other side. And you've done it. Without even worrying about showing that, you've done it. Okay, so x is the square root of 6 pi. Sometimes they might tell you to work out the value of k. Remember, integer is just a whole number, and that's it. X is the square root of 6 pi. Next, we've got solving quadratics. So normally you might be used to seeing it in the form where it's x squared plus something equals 0. Here it's a little bit trickier, but that's not to be something to worry about. All you need to do is rearrange it and get it in the form x squared blah 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 equals 0. So we want to move everything to the other side, so we'd do the inverse. So we would subtract 5x from both sides, and then we would subtract 24 as well. So x squared, take 5x, take 24 equals 0. So now you've got your equation in a form where it equals 0, and we can factorize it. Now when we're factorizing, we're looking for numbers that multiply to make negative 24. So you could have 1 and 24, 2 and 12, 3 and 8, 4 and 6. But this pair, and it's important it's a pair, you need to choose the ones that are pairs. You can't choose 1 and 8, you need to choose the pair. So they need to also add to make negative 5. Now the key here is that it's not 24, it's negative 24. So when your result is a negative number, you know that you've multiplied a negative by a positive to get a negative result. So one of the pair needs to be a negative, the other is a positive. So 3 and 8, I know that they multiply to make 24, and I could wiggle them around to make negative 5. So let's think about it. Minus 3 plus 8 gives you positive 5, so that wouldn't work. But negative 8 plus 3, that gives you negative 5. So you know that negative 8 and plus 3 is your pair. So you can just try these around. Obviously, if you try 24, you'd be like 24 plus 1, that's negative 23, it wouldn't work. So if it's not immediately obvious to you, just try some out. So you've got negative 8 and plus 3. You put your little things in brackets, and all you do is you put one will have negative 8, one will have plus 3. Okay, so you factorized it now. You found your factors, put it in brackets. This is just a simple x squared. So you know whenever it's an x squared and you factorize it, it's always going to be like that, x plus something, or x minus. Okay, so now we need to solve it. Now to solve it, remember what we do to one side of the equation, we do to the other. So what I could do is divide both sides of the equation by one bracket at a time. So divided by x plus 3 divided by x plus 3. Now 0 divided by anything gives you 0. So when you divide by the brackets, it doesn't change. It still stays a 0. So you'd have x take away 8 equals 0. Then to solve it, you move the x on the 8 onto the other side. So x equals 8. That's one part. A quadratic is always going to have, usually, it's going to have two answers. So you've got x equals 8. Then we do the same. We imagine that we haven't deleted that x plus 3 bracket. We're going to divide both sides of the equations by x take 8. And we'd be left with x plus 3 equals 0. So what do? We subtract 3 from both sides and we're left with x is negative 3. Now, some of you like shortcuts. So the shortcut is whatever you have in the bracket, it's your answer is always going to be the inverse. But it's good to know why. And that's your answer. So your answer would be x is 8 or x is negative 3. And next we've got the laws of indices. So hopefully you know that anything to the power of 0 is always going to be 1. I'll just quickly demonstrate why. So let's say you had 2. So we've got 2 squared, 2 cubed, 2 to the power of 1, 2 to the power of 0, 2 to the power minus 1. What happens each time? Well, 2 cubed, oh, it just deleted itself. 2 cubed is 8, 2 squared is 4, 2 to the power of 1 is 2, 2 to the power of 0, I don't know yet. But what is happening each time? Hopefully you can see it's being divided by 2 because over here we're multiplying by 2. Okay, so if we followed the pattern, what would the answer to 2 to the power of 0 have to be? Because maths follows a pattern. So 8, 4, 2, you'd have to divide by 2 again, and 2 divided by 2 is 1. And then obviously 2 to the power of negative 1 would be a half, and so forth and so forth. But just in case you didn't know, anything to the power of 0 is 1. So that's something you should write down if it's something you haven't already got. Then we've got multiplying indices. So when we're multiplying indices, we just add the little powers. So 3, even though it doesn't have a little index number, we can write it as 3 to the power of 1, just to make life a little bit easier for ourselves. So what do we want to do? We want to add these little powers. So 1 plus 6 is 7, and 7 take 6 is 1. So your final answer would be 3 to the power of 1, and anything to the power of 1 is just itself. So that would just be 3. So hopefully you know the laws for multiplying. Indices, you just add the powers. Okay, now we've got a slightly trickier one, which is a negative indice. So when we've got a negative indice, it is just the inverse. So all you do is you write it as 1 over what it would be if it was positive. So let's say it was 3 to the power of minus 6. That would be 1 over 3 to the power of 6. So ignore the little negative sign and write it as 1 over what it would be. Now 2 to the power of 4, it says find the value, which means the actual amount. So you're going to have to do 2 to the power of 4. So 2 times 2 is 4, times 2 again is 8, times 2 again is 16. So that would be 1 over 16. And then we have to find the value of 27 to the power of a third. Now, when you've got a fractional indice, the little, the numerator is what it would be to the power of, and the denominator is what it would be to the root of. So in this case, we don't have it being to the power of anything. We just have it to the root of something. And the root is 3, so it would be the cubed root. So you'd write that as the cubed root of 27. And this is a non-calculator paper, so you're expected to know your cube numbers. So that would be 3, but if you didn't, then you're just going to have to try and write them out. So you could have done 2 times 2 times 2, that would be 8, it doesn't work. 3 times 3 times 3, 3 times 3 is 9, times 3 again is 27. Okay, so ideally you are going to know your square and cube numbers up to 10 at least, hopefully up to 15, or at least be able to recognize them. And that's how we do that. Next, we've got area and square root problem solving. So it tells us that we have a diagram made from 6 identical squares, and the total area of the shape is 5,406 centimeters squared. Okay, so we need to find an estimate for the length of one side of each square. Now this is really super important. People always miss this out, and that's why they get this question wrong. Estimate, okay, that means we are working with really easy numbers. So there are 2 ways you could do this. You could round it first, or you could work out the actual value and then round that. I'm going to go with the second option, but you could just round this to 4,500 if you wanted to. So the total area of the shape is 5,406, and there are 6 identical squares. So I'm going to do 5,406 divided by 6. So 6's into 54 are, well, into 5 are nothing, then into 54 are 9, 6's into 0 are 0, and 6's into 6 go once. So the area of each little square is 901 centimeters squared, but I am being asked to work out an estimate for the length of one side of each square. And if you know the area of a square, to work out the side length, you would just do the square root. Like if you knew that the area of this is 25, you know instinctively that it must be, the sides must be 5, because 5 times 5 make 25. But what you would have done is do the square root of 25. So similarly, I'm going to have to do the square root of 901, but it's an estimate question. So the whole point of estimate questions are to make your life easy. So it's not going to be easy for me to know the square root of 901 without a calculator. So I just round it to a number whose square I do know. So the square root of 900. I mean, you might not know it off by heart. Hopefully you do, but it's an easier number to work with. So you think to yourself, what number multiplies by itself to make 900? And that would be 30. I mean, if you didn't know that, then just think to yourself, okay, I know the square root of 9 is 3. So the only other thing I could do, so it's obviously not 3. Maybe if it was 30, that's 10 times on both sides. So 3 times 3 is 9. Add on the 2 zeros is 900. So you just have to figure out ways to make it work if that wasn't, if it wasn't a square number you already knew. Now the next part of the question says, is your answer an underestimate or an overestimate? Well, I've rounded the area down. So you'd say it's an underestimate because I rounded the area down. So think about what you've done and what the impact would be to your number. Like if you had the square root of 1,000, that would be more than the square root of 900 because it's a larger number. Like the square root of 25 is 5, the square root of 16 is 4. So as the number gets larger, the square root will also get larger. So that's why it's an underestimate, because you rounded the area down before you square rooted it. Okay, so here we've got another case of forming and solving equations, and we are shown 2 rectangles and told that their areas are equal. So knowing this, what we want to do is find an expression for the area of each rectangle. How do you work out the area of a rectangle? You just do length times by width, or base times height. So rectangle A is going to be 6 brackets 2w plus y. When there are 2 terms for a length, we just put them inside a bracket. And when we've got a bracket, all that means is that everything inside of the bracket is being multiplied by what's outside of the bracket. So that's why we do that. That's why we put the brackets in. And for the area of B, we do 7w times by 3y plus 6. Remember, the bracket implies the multiplication. So we know that the area of A, which is 6 brackets 2w plus y, is equal to 7w at 3y plus 6. Okay, so that's the first part. We've formed our equation. And now we need to solve it. It says find an expression for y in terms of w. So our final answer should be in the form y equals, and then lots of little w terms. So first thing we can do is expand the brackets. So 6 times 2 is 12w plus 6y equals 21wy plus 42w. Okay, so we've just expanded the brackets. Now we want to get it in the form y equals, which means we want to isolate the y term. Unfortunately, we've got a wy term, which means that we're going to have to factorise at some point. So what we could do first is simplify as much as we can. So we've got 12w on both sides. We've got a w term on both sides of the equation, so we can just eliminate 1 by subtracting 12w from both sides. So we're left with 6y equals 21wy plus 30w. And now what we could do is bring the wy term to the side that only has a y term, because then I can factorise it. So I'd say 6y take 21wy equals 30w. So now I've got the y terms on one side of the equation, I can factorise. And when I factorise, I can extract the y term so that y is on its own. So let's factorise the y out. So I'm going to put y on the outside of the bracket, and then y times 6 gives you 6y, and y times by 21w gives you 21wy. So because I'm trying to get my expression for y, it's really important I get y on its own, which is why I've only extracted y. Obviously there are higher common factors, which you normally do when factorising, but in this case we just want the y term, which is why I haven't used the highest common factor. I've used the factor I want, which is y. So that equals 30w, and then all I do is divide both sides by the bracket. So let's divide by 6, take 21w on both sides, and you've done it. So y equals 30w over 6, take 21w. That's it. So this is a tricky question. Don't let the fact that it's so tricky and there's so many parts put you off. Just work through it step by step. And even if you just get to the part where you've formed the equation and expanded the brackets, that's still going to get you marks. So if the latter part of the question freaks you out, obviously watch videos on forming and solving equations, especially ones that require you to factorise. But if even if that scares you, just still have a go at it, because you can pick up marks. So here we've got cumulative frequency, and all that means is like the running total. So you add everything that's come up and you keep it in a growing total. So the cumulative frequency table gives information about the heights in centimetres of 40 plants. On the grid, draw a cumulative frequency graph for this information. Okay, so when we're drawing cumulative frequency, we always want to plot it against the largest interval. So it's obviously going to be from 0 because it's a cumulative frequency, so the end point. So we plot it at 5 and 4. Ooh, so try to move it. So then we plot it at 10, 11. So I'm plotting against the highest interval, and then obviously the cumulative frequency. Then 15 and 24, 20 and 34, 25 and 38, hard to see on the screen, and 30 and 40. Okay, so always when you've got a cumulative frequency, it's kind of going to look like a little bit of an S. So let's join it up. And it's a bit... Okay, there we go. And that's all you do for cumulative frequency. So you plot against the highest interval, and then against the cumulative frequency. Now it says use the graph to find an estimate for the median height of the plants. Now this is where people so many people make this a mistake over here. So you were using a graph to find the estimate for the median height of the plants. Now, what people tend to do is they're like, oh yeah, the height, so I'm going to find the half of the height. But no, you want to find an estimate for the median height of the plants. And how many plants do you have? You've got 40 plants, and it's always going to basically be your cumulative frequency. So you're finding the median of your cumulative frequency, how many plants you have in total. So the median is the middle value. So half of 40 is 20. So what we do is we find the 20th term and we go across. So we go across to our cumulative frequency, and then we go down, and then we try and read it. So this would be 12.5. So it must be going up in 0.5. So that would be, oh no, oh, what did I do? Okay, so that would be 12.5, 13, 13.5, 14. Okay, so the median height of the plants would be 14 centimeters. So if you were asked for the lower quartile, you would go across from 10, upper quartile, you would go across from 30. Okay, now we've got a recurring decimal to fraction. So always with questions like this, it's good to actually try and do it for yourself, because then you can sort of spot where they might have gone wrong. So what would I do? Well, I would say x is 0.43 recurring. And then maybe I would try out 10x. So that would give me 4.34 recurring, 34 recurring. Now, the whole point of recurring decimals is that you're trying to get to a part where you can eliminate the decimal. So whatever's after the decimal point, the recurring part needs to be the same. Obviously 0.43 is not the same as 0.34, so that doesn't work. So that's why Ted's method isn't working. What you should have done, what I would do then, is be like, okay, they don't match up, so let's try 100x. So that would be 43.34, 0.43 recurring. So you've got the same recurring decimal after the decimal point. The reason you do that is because if you said 100x is 43.43 recurring and the x was 0.43 recurring, and then you subtracted them, that recurring decimal, 0.43 recurring, take 0.43 recurring, cancels out, so it would be 0. So you'd just be left with 43. So 99x would be 43, and x would be 43 over 99. So what Ted has gone wrong, because you are being asked to evaluate Ted's method. So a good practice is just show what you would have done and then put it into words. So this is what I would have done. So what he did wrong is he doesn't eliminate the recurring decimals. And that's the whole point of what we do and why we say x is our value, and then we multiply it by 10 or 100, because we get to a point where we can eliminate the recurring decimals. So that could be one reason, or you could have said he should have used 100x, because that's the value at which we get to eliminate the decimals. Okay, so that's a recurring decimal to fraction. Okay, so here we have a compound shape and expanding and simplifying brackets. So how would I do this? Now, compound shape is just made up of a complicated shape made up of two easy shapes. So hopefully here you can see it's made up of two rectangles. You could split these up any way you wanted to. I'm going to split them up this way. Okay, so I've got one little rectangle here and then another one over here. So my length of this whole height here is x plus 11. I know that this length here is 4. So to work out this length here, I would do x plus 11, which is the length of the total length, and I would subtract 4. So 11 take 4 is 7. So this length here must be x plus 7. So I've worked out what my length over there is. I know what the lengths of my other rectangle are, so I can work out the area bit by bit. So let's do the top part of the shape first. So I've got x plus 1 times by 4. And remember, when we are multiplying more than one term, we put it in brackets. So the area of this shape would be 4x plus 4 once I've expanded it. So that's 4x plus 4. And now let's work out the area of the other rectangle. So this part here. So I've got a length of 2x plus 6 multiplied by a length of x plus 7. So we've got brackets, so you're going to have to expand them. So 2x times by x is 2x squared. 2x times by 7 is 14x. 6 times x is 6x, and 6 times 7 is 42. Now let's just simplify the middle two terms. So you've got 2x squared plus 20x plus 42. And that's this part. So 2x squared plus 20x plus 42. Okay, so you need to show that the total area is 2x squared plus 24x plus 46. Well, all we do is we add the two areas together. So 2x squared plus 20x plus 42 plus 4x plus 4. So I've just added the two separate parts. Now let's combine the like terms. So you've got 20x plus 4x. So your final thing would be 2x squared plus 24x, and then 42 plus 4 is 46. And I believe that is your area. Yes, it is. So this is how you have shown that the area is 2x squared plus 24x plus 46. Okay, over here we have got some algebraic fractions. So remember, just like with any fractions, in order to add or subtract fractions, they need to have the same denominator. So what would the lowest common multiple of these two fractions will be? Well, the lowest common multiple of 2x and 5, because it's algebra, we just multiply them together. So 5 times 2x is 10x. So our denominator should be 10x. Okay, so now I need to think, what have I multiplied this fraction by to get to 10x? Well, 2x, if I multiply that by 5, that gives me 10x. So I have to multiply each part of the fraction, so numerator and denominator, by 5 to keep it equivalent. So that's what I've done there. And then over here, what have I multiplied 5 by to get to 10x? I multiplied that by 2x. So I have to multiply 3 by 2x as well, which is 6x. So let's just expand the bracket here. So that would be 20x plus 15. And the reason I want to have the same denominator is because when fractions have the same denominator, you can write them as one fraction over the same denominator and just add their numerators. So 20x plus 15 plus 6x is what my fraction would be. And then just bring together the like terms. So you've got 20x plus 6x. So that would be 26x plus 15 over 10x. And that's how you've got. So I think this question also scares a lot of people because it says can be written in the form blah 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 where a and b and c are integers. Integers just means a whole number, and they've just shown you what it's kind of going to look like. So hopefully you can see that a, b and c are just numbers. So a is 26, b is 15, and c is 10. So don't let the fact that they tell you to write it in this form scare you off. Just do what the question has asked you to. So you know you're adding fractions. So what do you do when you add fractions? You find this same denominator, then you just add them. It's a little bit trickier because it's got algebra in it. Okay, probability tree. So over here it says there are only 3 red and 5 yellow counters in a bag. Jude takes at random 3 counters from the bag. Work out the probability that he takes exactly 1 red counter. Okay, I'll just use red and yellow for this, just to make it easier. So we've got 1, 2, 3 red counters and 1, 2, 3, 4, 5 yellow counters in the bag. So what I want to do is set up my probability tree. So I'll just set it up like a normal one. So I'll just do it red and yellow. It'll just take a little bit more time. Okay, so I've got a chance to take a red counter first. What would the probability of that be? Well, I've got 8 counters in total and 3 of them are red. So the probability would be 3 over 8. Then I have the option of taking a yellow counter. There are 5 yellow counters in total out of a total 8. So the probability for the first counter, would be 3/8 or 5/8. But Jude takes 3 counters from the bag. So then for each of my branches, I need to do another branch. So there's an option of having a red or a yellow. So if I took a red counter, but I'd already taken a red counter, that means there's only 7 counters left. Okay, so for the second branch, everything is going to be out of 7 because you've already taken a counter out. There's 1 less counter. And if you've already taken 1 red counter, then that means there's only 2 potential red counters left. Okay, same for if you took the yellow. So you've taken a yellow counter. How many red counters will be left? Well, there's still 3 because you haven't used any of them. So that would be 3/7 here. I'm doing this a little bit like normally I'd do it branch by branch, but it's because it's different colours. So let's go back here. So if you've already taken a red counter, there's 7 counters that will be left, and you haven't touched the yellow ones. So the probability of picking a yellow one would be 5 out of 7. So let's just yellow. So that's how you do your little branches. And then let's do it again because this is for the third counter. So for the third counter, you also want to have, I'm just going to do it like this. You have a branch for each thing. So if you have taken 2 counters out, then all of your probabilities are going to be out of 6 because there are only 6 counters left. If you've already taken a red counter, 2 red counters, then there's only going to be 1 red oh, why has it deleted it? There's only going to be 1 red counter left. So the probability of getting a red on the third time would be a 6th. If you've taken a red and then a yellow, you've taken 1 red counter, so that would be 2 red counters are left. So that would be 2/6, like the same over here, and over here it would be 3/6. And then for the yellow, so you've taken no yellow counters. It's all going to be over 6. All the probabilities are over 6 because there's only 6 counters left. And there's 5 yellow counters in total. You haven't yet taken a yellow counter, so you'd say 5 over 6. Over here for the next one, you've already taken, if you go along this route, you've taken a yellow counter, so that would be 4 over 6. Same over here, you've taken a yellow counter, so it'd be 4 over 6. And over here, I've actually made a mistake. That should be 4 over 7 over there because you've taken a yellow counter already. And therefore there should be 3 over 6. So we want to work out the probability that he takes exactly 1 red counter. So what we want to do is find which route we can take. So if we take red, 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 red doesn't work because that takes out 3 red counters. The next route I could take is red, red, yellow. But red, red, yellow also doesn't work because that gives me 2 red counters. Next route I could take is red, yellow, red, red, yellow, red also doesn't work because that is 2 red counters. So I could take red, yellow, yellow, red, yellow, yellow. That works because I only have 1 red counter. So when I go along the probability branches, I multiply it. So that would be 3/8 for red times by 5/7 times by 4/6. Okay, so that's one option. Then you could do yellow, red, red. That wouldn't work. Yellow, red, red would still be 2 reds. You could do yellow, red, yellow. Yellow, red, yellow would work. So you've got 5/8 times by 3/7 times by 4/6. What other route? So yellow, yellow, red. Yep, yellow, yellow, red would work because there's only 1 red counter. So that would be 5/8 times by 4/7 times by, oh, what did I say? Yellow, yellow, red, 3/6. And then obviously the final route is yellow, 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 which gives you no red counter, so you wouldn't use that. So let's multiply these. So 8 times by 7 times by 6. Oh, my brain has stopped working. So 8 times by 7 is 56. So let's just use the lattice method. Ugh. hold on. So 8 times 7 is 56, 6 times 6 is 36, 5 times 6 is 30. So that would be 6, 3, 3. So it would be over 336. All our probabilities would be over 336. And then 3 times 5 times 4. So 5 times 4 is 20. 20 times 3 is 60. Let's do it again. 5 times 4 is 20, times 3 is 60. 5 times 4 is 20, times 3 is 60. Okay, so what we do when we do a probability tree, we obviously draw it all out first. Then we see which roots would satisfy what they want. So they want to know the probability that he takes exactly one red counter. And then once we've worked out what that probability is, we add them together. So we'd add 60 over 36 plus 60 over 36 plus 60 over 36, which would give you 180 over 336. So that is the probability that he takes exactly one red counter. You can also do this question without doing the probability tree, but I would only recommend doing that if you're extremely diligent and you have listed all of your options out. Otherwise, it's really easy to just miss something. And that's probability trees. Okay, so in this question, we are looking at inequalities. We're going to need to draw them on the graph and then shade the region which satisfies all of them. So let's start with the easiest one, which is this: x is less than 3. So what you do when you've got your inequalities, you imagine that they're a straight line. So in this case, the line x equals 3. You draw that on, and then you decide where on that line the region would be. So the line x equals 3 means that I need every line, every x coordinate on the line to be 3. So obviously you go to the x-axis, you see where 3 is, and all of these coordinates here, the x coordinate is 3. So you've got 3, 6, 3, 5, 3, 4. That's how you decide whether it's an x equals line, which are always vertical because it's the x coordinate that's always the same, or a y equals, which are always horizontal. So that would be the line x equals 3, but I'm not drawing that line. I'm drawing the line x is less than 3. So once you know where that line is, you then, if it's a solid line, it would mean it would be less than or equal to 3 or greater than or equal to 3. But it's not, it's just less than, so therefore it's a dotted line. So if it's less than or equal to, it's a solid line. If it's less than, it's a dotted line. Okay, that's how you know the difference. So we've done the first one. Okay, now we've got the next few, which is going to be slightly trickier. So let's just get rid of that working. So let's try the first one. So all of your lines you generally want to be in the form y equals, because every straight line should be in the form y equals mx plus c. So let's just have a go at rearranging this. So we turn it into an equals so that it's an equation of a line, and we rearrange it. So we subtract 4 from both sides. So we've got 2y equals x take 4, and then we're going to divide both sides by 2. So y would be x over 2 take 4 divided by 2, which is 2. So remember, you have to do the operation to each part of each side. So x take away 4, that's 2 terms, so you have to divide both of them. So we've got y equals x over 2 take 2. What I'm going to do is just draw myself a table of values, and it's quite a large grid, so I'm just going to go from -6 to 6, but I'm going to go in using the even numbers and intervals of 2. So the best thing to do is always start from the positive number, because it just makes your life easier. So let's say 6 divided by 2 is 3, take 2 is 1, 4 divided by 2 is 2, take 2 is 0, 2 divided by 2 is 1, take 2 is -1, 0 divided by 2 is 0, take 2 is -2. So I can obviously see this pattern and I know that it's going to work. It's a little bit risky to do it so soon, but what you can do is spot a pattern. It goes down by 1 each time, and you can only use patterns if the intervals that you've done your table of values are equal. So if it's going up in 2s each time or 1s. So I know it's going to go down, so I'm just going to fill it in. Now, just in case you have made a mistake, it's always good to check the last one. So -6, let's try that. So -6 divided by 2 is -3, take 2 is -5. So you know you've done that right. Okay, so if you do want to do the little, what's the word? Shortcut, that's fine as long as you double check. So now let's draw this line, and I'll make it pink just so that it's, so -6, -5, -4, -4, -2, -3, 0, -2, 2, -1, 4, 0, and 6, 1. Okay, so you've drawn your line. Again, it's a less than line, so it's going to be a dotted line. Actually, so now I know where it is. I'm just going to get rid of the X's because they're a bit clunky on here. So draw your line. Okay, and I was supposed to do it dotted. Okay, never mind. Anyway, it'll be a lot more accurate when you do it. So you've got that line there. And okay, there is something I missed out. So the line x equals 3 we've drawn here, and we need to determine what region satisfies it. So x needs to be less than 3. So your x values need to be less than 3. So this, in this direction here, I won't do all of it because it's not going to cover all of it, but if it was just the line x equals 3, all of that region would be satisfied. However, you've got quite a few inequalities, so I'm just going to put the lines up here as a reminder. Now for the next line, the one we just did, it was 2y plus, so y would need to be less than x over 2 take 2. So the y values would need to be less than the line. This is the line y equals x over 2 minus 2. We rearranged it. And your y values need to be less. So look at your y-axis. It's this direction here that it needs to be going. Okay, so this is the general flow. So it needs to be everything going that way and downwards. It'll become a bit clearer when we get the final one. So let's get the final one done. So the next line we've got is y is less than 6 take 3x. So once again, this one's already done in the y equals form, so we don't need to do anything to that. Let's just do our table of values, x and y. Once again, I'm just going to do going up in 2, so -6, -4, -2, 0, 2, 4, 6. Okay, so 6 take 3x, so 6 take 18 is -12. That won't appear on the graph. Then we've got 6 take 12, which is -6. Then we've got 6 take 6, which is 0. Then we've got 6 take away 3 times 0, which is 0, so that would be 6. And then we've got the negatives. Now, right, so we've got 6 take 3 times -2. So 3 times by -2 is -6. So we'd have 6 take away -6, which is 12. Now, obviously, you can see that that's going to go above the graph, so there's no point in doing the rest. Okay, so they're going to be off the graph. So we've got our 4, 3 coordinates here. So we've got 0, 6, we've got 2, 0, and we've got 4, -6. Now, in this case, you might want to work out the coordinates for 3 and 1 if you wanted to make your graph more accurate. So, for instance, for 3, if x was 3, y would be 6 take 9, which is -3. And over here for 1, if x was 1, 6 take 3 is 3. So you could do that to make it more accurate. Once again, it's a less than. So y is less than. So we draw a dotted line. And that's our line. So the y coordinate has to be less than this line. So it's going to be everything down here in this region. So what we need to do is think about which part of the graph satisfies all of these inequalities. So it needs to be less than 3, so going in that direction. It needs to be less than the pink line and less than the green line. So the region that satisfies all 3 of these would be this part here. Okay, so all of this over here. Now, but But it's really important that this section here isn't shaded in, because that wouldn't satisfy the x is less than 3 region, and this region here isn't shaded either. Okay, so it has to be something that satisfies all 3 regions. Okay, so here we've got a trapezium and trigonometry question. Now for this question, it's important that you know your exact trigonometric values. If you don't, make sure that you learn them. So here is a trapezium. Now what's the formula for the area of a trapezium? The area of a trapezium is the 2 parallel sides. So we can call that a plus b times by the height, the perpendicular height. So like this, divided by 2. There are lots of ways you can write this formula. You could write it as half a plus bh, whichever formula works best for you, you use that. So that's the formula for the area of a trapezium. We've been told the area of the trapezium, and we've also been told that the length of AB to the length of CD is 2 to 3. So once again, this is a ratio question, so 2 parts to 3 parts. So what we could do is just use algebra to make our life easier. So we'd say that's 2x and that's 3x, 2 parts to 3 parts. We need to find the length of AB. Okay, so in order to find the length of AB, which would be like the 2x part, we need to know what the height is. First of all, so what we could do is use a little right angle triangle over here, form it here. So we've got our right angle triangle here, and we want to work out the perpendicular height, the height of the trapezium, which would be this length here. So how do we do that? We've got this right angled triangle. We know the hypotenuse, which is 6, and we're trying to work out, this is our angle here. So remember, in trigonometry, everything is in relation to the given angle. So in this case, this is our angle, and this would be the opposite sides. So I've got O and H. So out of SOHCAHTOA, I would use SO, because I've got O and H. So I'd say sine theta is opposite over hypotenuse. Now a theta is just the size of the angle. In this case, that's 30. So I'd say sine theta equals opposite, which is what I'm trying to find out. So let's keep it as opposite for now, over the hypotenuse, and the hypotenuse is 6. Sorry, I was supposed to write in 30 there. Okay, so sine 30 equals opposite over 6. Now this is where you're expected to know your exact value, so you should know that sine 30 is a half. Don't worry if you don't, they're just things that you can memorize, or there are ways that you can learn them, but just for the sake of this, let's assume you know them. So sine 30, the value of sine 30 is a half. So we'd substitute that in. So we know that a half equals opposite over 6. To work out what the opposite is, we'd multiply both sides by 6. So 6 times a half is 3. So the opposite side must be 3. Now, what does the opposite side represent? Well, it represents the height. So the height of our trapezium equals 3. So I'm just going to get rid of this working. So screenshot it or pause if you need. And now, what do we do? So we've got our height, which is 3. So the area of the trapezium, we don't know what AB and DC are. All we know is that they are in the ratio of 2 to 3. So we've labelled them as 2x and 3x. So we use the formula for the trapezium, and we'd say A, which is 2x plus 3x. So A and B are just the 2 parallel sides, this here, AB and DC. That's what we're dealing with. We multiply that by the height, which we worked out was 3. And we would divide that by 2, and that must equal 66, because we've been told that the area of the trapezium is 66. So all I'm doing is substituting into that formula. So let's simplify that. So we've got 2x plus 3x, which is 5x, times by 3 is 15x, over 2 equals 66. Then what could you do? You times both sides by 2. So 15x, let's get rid of this. 15x equals 132. And then what do? Well, you're going to have to divide 132 by 15. So there are lots of ways you can do this. I'm just going to do the division. So is that what I'm going to do? Yeah, 132 divided by 15. There's no point of doing this. So let's just do our 15 times tables. We've got 15, 30, 45, 60. So 1, 2, 3, 4. Oops. 75, 90, 105, 120, 135. Okay, so we know that 15s into 132 go 1, 2, 3, 4, 5, 6, 7, 8. 8. Remainder from 120 to 132 is 12. So we put a 0 here and the remainder of 12. So how many 15s go into 120? 1, 2, 3, 4, 5, 6, 7, 8. 8.8. So x is 8.8. Okay, so we figured out what x is. And we know that the length of AB is 2x. So therefore 2x would be 8.8 times 2, which is 17.6. So AB equals 17.6. So quite a tricky one there, but it's all about forming and solving your own equation. The thing that might have caught people out is knowing the trigonometric values. So please make sure that you know your exact trigonometric values. Okay. Next question, we've got surds and rationalising the denominator. So when you're rationalising a denominator, all you're trying to do is basically ensure that the denominator doesn't have a surd in it. And if there are two terms on the denominator, then what you're going to have to do is like the inverse of it. So in this case, we've got 5 plus root 3. The inverse would be 5 take root 3. So the inverse of a surd. So if it's a plus, it would be minus the surd. If it's a minus, then it would be plus the surd. So let's see what we can do first. And generally, if it's a show that question or anything to do with surds and there's a surd on the denominator, you're going to want to rationalize it. Okay, so let's see if there's anything that we can do. Well, the first thing I would do is, I know that the numerator has the square root of 12, so that's not in its simplest form. So I'm just going to simplify that to make life easier for myself. So root 12, what's the largest square number I can think of that fits into 12? That would be 4. So I know that root 12 can be written as root 4 times by root 3. So the reason I'm doing that is just because some people find it easier. I could also write it like that, but then you'd need to know to take out the square root. So I'm just going to do it the way that I do it. If you do it another way, that's absolutely fine as long as you know what you're doing. So the square root of 4 is 2. So that would give me 2 root 3. So root 12 can actually be written as 2 root 3. Now that makes my life easier because the denominator is already expressed as the root of 3. So that's just a little quick thing to help me. So I'm going to write this here just to make more space. So root 12 is root 3. So let's see what I can do. So I'm going to write that as 8 plus 2 root 3 over 5 plus root 3. And to rationalize it, so like I said, if there's two terms on the denominator, then you do the inverse. So that would be 5 take root 3 over 5 take root 3. And the reason you do that is because when you're expanding brackets, if you have one that has a positive, one that has a negative, the two middle terms cancel out. So you're getting rid of your surd basically. Remember, when you're rationalizing, you multiply both the numerator and the denominator by whatever you've chosen because you want to keep the fraction equivalent. So let's see what we do. So we've got 8 plus 2 root 3 times by 5 take root 3. Let's deal with the numerator first. So we've got, let's do it in a different colour. Sorry. 8 times 5 is 40. 8 times negative 3 is minus, where's it gone? Minus 8 root 3. 2 root 3 times 5 would be 10 root 3. And 2 root 3 times by root 3. So if you're stuck on that, it's the same as doing this. 2 root 3 times by root 3. And obviously, what's root 3 times root 3? That would be 2 times root 9. What's root 9? 3, so that would be 2 times negative 3. So that would be negative 6. Okay, so that is a little bit of a tricky one. So just spread it up. You've got 2 root 3, which means 2 times root 3, times by negative root 3. That would simplify to root 3 times negative root 3 would be negative root 9, 2 times negative 3. Okay, so that's my numerator. Now let's do the denominator in a different colour. And obviously you could simplify these two to be, let's simplify it over here. So, and you could simplify the top. So 40 take 6 is 34. And minus 8 plus 10 is 2 root 3. But that's the simplified version for later. Now let's do the denominator. I'd write it out here. So 5 plus root 3 times by 5 take root 3. 5 times 5 is 25. 5 times negative root 3 is negative 5 root 3. 5 times root 3 is 5 root 3. And root 3 times negative root 3 would be negative 3. So you've got over 22. Now, can you see, this is why we do the rationalising surd, because this and this cancel out. It's going to be the same thing. A minus and a plus cancel out. So that's why we do it. That's the whole point of rationalising the surd, because you cancel out the two middle terms and you're just left with an integer as your denominator. So there we go. That's that. We've shown how it can be written in the form a plus something root 3 over 22. Okay, so here we've got some simultaneous equations, and we need to find estimates for the solutions. So really, actually, solving simultaneous equations graphically is so simple and so easy, because all you have to do is draw your little lines, or obviously with a quadratic it would be a curve, and then see where they meet. And then the solutions is the coordinates of where the two lines meet. So we've been given x squared plus y squared equals 30.25. We've been drawn that. And all we need to do is draw the line y, take 2x equals 1. So it's always like nice to just get your line in the form y equals. So that would be y equals 2x plus 1. Then over here I can do my little values, so x and y. I'm going to do minus 6, minus 4, minus 2, 0, 2, 4, 6. So really quickly, 2x plus 1, 2 times 6 plus 1 is 13, 2 times 4 is 8, plus 1 is 9, 2 times 2 is 4, plus 1 is 5, 2 times 0 is 1. There you can see that it's going down in 4s each time, so that'd be minus 3, minus 7 and minus 11. Let's just double check by doing the last digit. 2 times negative 6 is negative 12, plus 1 is negative 1. Perfect. So now let's plot the line. So we've got minus 6, 11. That doesn't appear on it. We've got minus 4 and 7 over here. Minus 2 and minus 3. 0 and 1. 2 and 5. And 4 and 9 doesn't appear. Okay, so here we've got a line. Okay, so I've drawn my line. Obviously you're going to use your ruler because you have a real pencil. And yeah, all I need to do is find the solution. So I would say, let's make that a little bit more accurate, that would be it's just over 2. So I would say the x is, I think anything between 2 and 2.2 would be fine. So let's just say x is 2.1 and the y value is 5. It's going up in 2s. Let's just say 5.1 as well. You use your, so over here, like you can see that this is where it crosses. I'm doing it really badly, but it's roughly like that. Over here as well. And remember, my line isn't as super accurate. So that would probably just be up here and over here. So that's one solution over here where it crosses, where 2.1 and what did I say, 5.1. And your next one is going to be here, which would be, let's say x is minus 2.9 and let's say y is 4.7. And there will always be a tiny little error margin. Obviously, hopefully, if you have this paper, you have it printed out in front of you and you would get a more accurate measurement. But that is all that you need to do to find estimates of solutions. Literally draw the line on, see where it intersects, and write down the coordinates. So it's always going to be 4 coordinates if one of them is a quadratic. So any part where they intersect. So obviously there's 2 points of intersection. So x is 2.1 when y is 5.1, and x is 2.9 when y is 4.7. You could write it as coordinates as well, like 2.1, 5.1, and so forth. Whatever you want, but that's that one. Okay, so next we've got functions. So functions is not something you should be afraid of. A lot of people seem to not like it, but it's actually pretty simple if you understand what's going on. So over here, we've got a composite function. We're being asked to work out g f of 1. So let's take it bit by bit. You always start from the inside out. So like the thing that's closest to the thing in brackets. So what I mean by this is start with f of 1. So let's work out what f of 1 is. So that means that if I put 1 into this function, what would my answer be? So if x was 1, so that would be 3 times 1 squared plus 1. So 1 squared is 1, 3 times 1 is 3, and 3 plus 1 is 4. Okay, so f of 1, therefore, is 4. So the value of f of 1 is 4. So you want to work out g f of 1. So you want to put f of 1 into here. So we've worked out that f of 1 is 4. So we want to put 4 into this. So figure out what the answer would be when x is 4. So let's try a different colour over here. So g of 4, which is technically g of f of 1, would be 4 over 4 squared, which is, what's 4 squared? 16. 4 over 16, which we could simplify to a quarter. Okay, so g of f of 1 is a quarter. So with composite functions, you start from like the outside in. So what's your bracket? You separate that first, and then figure what that out is and insert it into the next function. And next we've got inverse functions. So, okay, so the function h is such that f of g of -1. Okay, so let's first of all work out what f of g of x would be. So, where's my pencil? Okay, so f of g of x. So what you're doing, again, start from the outside in. So g of x, we know, is 4 over x squared. So we're going to substitute that. Oh, where's it deleted it? So we're going to substitute this into f of x. So basically saying f of 4 over x squared. So that would be, oh my gosh, I don't know why it's deleting it. Okay, so f of g of x would be 3 times by x squared, so 4 over x squared plus 1. So this bit is obviously its own little thing. I don't know why I did that so big. So let's deal with the square bit first. So over here, that would be 3 times 4 squared would be 16, and x over 2 squared means times by itself. So that would be x to the power of 4. And then you'd add 1. So what's 3 times 16? 16, 32, 48. So that would be 48 over x to the 4 plus 1. So f of g of x is that. Now what we need to do is find the inverse, okay? So when we're finding the inverse, what we do, let's just get rid of that, is we say, okay, so if my equation was y equals 48 over x to the power 4 plus 1, what would the inverse be? And to get that, I have to make x the subject. So you rearrange everything to get x to the subject and you find the inverse function. So we'd say y take 1 is 48 over x to the power 4. Next step, we'd multiply both sides by x to the power of 4. So x to the power of 4 times by y take 1 equals 48. We're trying to make x the subject, so we'd eliminate the y. So x to the power of 4 is 48 over y to the minus 1. And then obviously x to the power of 4, the inverse of that would be the fourth root, the root with the 4. So we would do that. So x would be 48 over y to the minus 1. Okay, so find h of x, and h of x is the function so that it's the inverse. So when it's the inverse, we switch the input and the output around. So the final bit is we switch the x and the y around. So h of x would be 48 over x take 1. Yeah, we've switched it around. Okay, and that's that. Okay, so we've come and made it to the last question. So it wouldn't be the last question if it wasn't a little bit tricky. So we need to find the coordinates of the turning point of a curve. Now, in order to do that, we can use completing the square. So let's have a look at this. Now, I've got this quadratic, and first thing I want to do is just write it in ascending order of descending order of powers. So let's write it as y equals minus 3x squared plus 18x plus 9. Now, the first thing you should notice is that each term in this equation is divisible by 3. So it's going to make my life a whole lot easier if I take out the negative 3, because then I can factorize, use completing the square a lot more simply. So if I did that, it would become x squared. So minus 3 times by negative 6x would give you 18x, and minus negative 3 times by negative 3 would give you positive 9. So let's just keep that separate for a bit. Now, what I want to do, just ignore that, keep it to the side, don't let it confuse you yet. I just want to focus on completing the square. So when I do this, essentially what I'm trying to do is factorize this. So I halve the middle number and I put it into brackets. So let's do this. Yeah, okay. So I've got, that would become x take 3 squared. Now I'm ignoring this part here. I'm only focusing on completing the square. I'll put the negative 3 back into play in a second. So just to show you why we do this when we complete the square. So x take 3 squared, what does that mean? Well, it means x take 3, x take 3. If I expanded that, I'd get x squared, x times x, then negative 3x, and plus 9. So that would give me x squared take 6x plus 9. So what I've done is I've basically got to a part where I've managed to get part of my thing factorized. So that's why I complete the square. But because of this, what I also do is I want to subtract the additional bit. So over here you can see that there's a plus 9. So what you're going to want to do is subtract 9 from here so that you end up with the same equation. Because if you had to get x squared take 6x, if you put that into brackets, you'd end up with x squared take 6x plus 9. But you want to just have x squared take 6x. That's why we subtract the 9. So it's only this bit we're dealing with. That's why we have to make sure that we're subtracting the square of the number in the middle. So once I've completed the square, also I've got a video on completing the square and turning points. This is just a really quick run through, so go and watch that if completing the square is something that confuses you. So we've got x take 3 squared take 9, and then I just put this in here, and that's inside your brackets. Okay, you do have the negative 3 on the outside. So let's simplify this and clear it up a little bit. So you've got x take 3 squared minus 9 take 3 is minus 12. So all of this is in a little bracket and it's all being multiplied by negative 3. So now that I've completed the square and simplified it, I can multiply out everything by negative 3 again. So that would just become negative 3 x take 3 squared, take 36. Now to find the turning points, all you do is you get the inverse of whatever's inside this bracket. So in this case, that will be 3. And the inverse, oh no, negative 3 times negative 12 should be positive 36. So the inverse of what's inside the bracket and then the leftover bit here. So the turning point would be 336.